Greetings and welcome, internet friends. Today, we're going to be solving radical equations, and I'm super pumped about this. I don't know why, but this is like one of my favorite topics. It's going to be good. So an example of a radical equation is any old equation. Let's see, do I get the right colors? I think I do. Any old equation that happens to have some sort of radical in it, whether a square root, cubed root, nth root, whatever. And yeah, we're going to learn how to solve those today. And you could probably guess it's related to using inverse operations, undoing the thing that's happening to the variable. So here it says solving radical equations. Step 1, isolate the radical. So get that square root by itself as much as possible on one side of the equation. And then square both sides in this case, right? Raise each side to the same exponent as the index of the radical. That makes sense. And then solve the resulting equation using other techniques. Good. And actually, very important is check your solution, because we're going to find out that on occasion we'll have some answers that are phony, the fakest of answers. So beware. So over here, okay. Example 1, let's jump right in. So a bunch of things happen in an x. It's being added by 1. It's being square rooted. It's being multiplied by 2. The first thing I'm going to do here to get, instead of trying to get x by itself, I'm going to get the radical isolated as much as I can. And so I've actually got to get rid of this 2 first. So my first step would be divide both sides by 2. And so I'd have the square root of x plus 1 equals 2. Now, I can't access anything on the inside of the radical, also called the radicand, remember, until I deal with this square root. And the way I'm going to deal with a square root, the inverse operation of square rooting is squaring. And so I'm going to square both sides of the equation. And notice this square root and that square undo one another. And so in this case, I'll get x plus 1 equals 4. And then subtract 1, I get x equals 3. Now, as far as doing a check, I think I usually do my checks in sky blue. This one didn't ask for us to do a check. They were setting us up for success, where it's not going to be anything crazy yet. But I would essentially just plug in my answer for x. So 2 times the square root of 3 plus 1, all under the radical. Is that equal to 4? Is it? And so I'd have what? 3 plus 1 is 4. Multiply that by 2. 2 times 2 is 4. So it does check out, right? Good stuff. And remember, when you're doing a check, you're not allowed to use inverse operations. You're following just plain old PEMDAS. All right, let's take a gander at this one. So this whole cubed root, I've got to get this by itself. Right now it's being subtracted by 1. So I'm going to move that 1 to the t'other side. And I've got the cubed root of 2x minus 9 equals 3. And in order to inverse a cubed root, in order to undo cube rooting, I've got to cube both sides. And so I'll have, notice wonderfully, the cubed root and the cube cancel out, just like a minus 1 and a plus 1 cancel out, just like a times 2 and a divide by 2 cancel out. These inverse operations are great things. They undo the thing that's happening to the variable. 3 cubed, remember, is 27. And now, man, your old Algebra 1 self could do this part. This is great. 36, div 2. And I get x equals 18. Ba-boom. Got him. And then, yeah, you could do a check, and I would plug 18 in for x and PEMDAS from there if it asked me to. Oh, here it looks like they are asking for it. Let's see. Just to speed run some of these. Here I would have squared both sides, and I'd get x plus 25 equals 4. Solve from there. Here I would have to divide both sides by 2 first, and I'd get cubed root of x minus 3 equals 2. And then how do I get rid of a cube root? How do I get rid of a cube root? I cube both sides. And all right, where's my pen? There we go. X minus 3 equals 8. And yeah, don't be afraid to reach for a calculator when you're cubing or squaring, things like that. Boom, boom. And then you solve from there. Solving a real life problem. Hurricanes. Here we go. Like smog coming down upon the outside of Erebor. Look out, men of Dale. Like a hurricane. Mean standard sustained wind velocity v in meters per second can be modeled by v of p equals this, where p is the pressure in millibars. Guys, to be honest, I don't know what a millibar is, but it's related to air pressure. Sounds good to me. At the center of the hurricane. Estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second squared. Meters per second, not squared. I was thinking about acceleration there for a second. And so I imagine I could replace the velocity, the output of this equation, with 54.5. Set that equal to 6.3 times the square root of 1013 minus p. Boom. And I've got my calculator within reach, fortunately. First thing I'm gonna do is divide by 6.3. How y'all doing today? I'm doing pretty good. Pretty good. 54.5, 6.3. Can't remember the name of the dwarf that says hurricane, but I've got the Lego minifigure in front of me right now. 8.65 roughly is equal to the square root of 1013 minus p. And now to get rid of that square root, you square, and you got to do it to both sides because that's only fair. Actually, even though I've got this 2 decimal approximation here, my calculator presently has the full decimal approximation. So I'm just going to hit the square button right now, and it says ANS for answer, and it'll take that full data, my previous answer, and plug it in, so that way it'll be more accurate, and I'll do my rounding at the end. So I got 74.84 after I round, is approximately to 1013. No, what am I doing? 1013 minus p, and minus 1013. Why do I keep writing that? Don't know why. Minus 1013 both sides. And I'm going to use this answer trick again. I'm just going to hit minus, and it automatically says answer minus 1013. And I get negative 938.16 is equal to the opposite of P. So pressure is equal to 938.16, and pressure is measured in millibars. I don't even know how to abbreviate millibars. But boom, that'll do. And so, yeah, well, I don't know what that means, but that's a hurricane happening right there. Your roller coaster's underwater. Woo! All right, so here's what I was warning you about. Look out. Sometimes you get extra solutions, extra fake solutions, where you did everything right. You obeyed all the laws of math, and even still, you're not good enough. It's so sad. It's like, problem, I can never make you happy. I did everything I was supposed to, and if you're not going to be satisfied with the answers that the algebra gave me, you're never going to be happy. Example 3. Here we go. So these are called extraneous solutions that are not actually solutions of the original equation. This problem's, this has got such good stuff going on it. Okay, so here we go. This square root, it's already by itself on its own side of the equal sign. So it's ready to square both sides. Now, x plus 1 all squared. Oh man, I bet I could fool a whole bunch of people with that. Remember, a plus b all squared. It is super illegal to distribute an exponent over addition or subtraction. But we did have a pattern for the square of a binomial, and it was called the perfect square trinomial pattern. By the way, this pattern is going to keep showing up throughout this course, so you might as well memorize it now. And so what do I get? X plus 1 all squared is going to be a squared plus 2 times a times b plus b squared. All right, I'm just like setting up this whole part right there, equals, this part's the easy one, those just canceled out, 7x plus 15. And so what are the a's and b's that I'm plugging in? Well, I'm plugging in x and 1. And so x here, x there, 1 here, 1 there. X squared plus 2x plus 1 equals 7x plus 5. Oh man, guys, so many skills are coming back. I had to remember my special pattern. Although you could have arguably, instead of x plus 1 all squared using the pattern, you would have been welcome to do x plus 1 times x plus 1 and done double distribution. You'd still get the same outcome. But now I've got a quadratic equation. And presently, for my students, the only way they know how to solve that is with factoring. I hope this is factorable. I've resequenced some of the curriculum. Hopefully I don't regret my choices. So I'm going to set this equal to 0 because I'm suspicious. Well, the only way I know how to factor and solve is if I use the zero product property, in which I set it equal to 0, factor, and solve. And so let's see, x squared. Oh yeah, this is gonna factor beautifully. Oh, maybe not. Oh dear. Oh dear, what did I do? What did I doodly doodly? Let me make sure I got all this right so far. Bop, 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 bop. All right, well, here's a typo. Transcription error. That was a 15. Let's carry that through. Actually, I don't even need to go that far back. 15, 15. All right, 15, 15. And so I've got 5x minus 14 equals 0. Okay, so since it's equal to 0, factoring and setting each factor to 0 is a possibility. In order to factor this, notice the leading coefficient's 1. Find the factors of 14 that subtract to be 5. You might have to go back to your chapter 7, friendos, and master your factoring skills. So the factors of 14 are 1 and 14, 2 and 7. Do either of those subtract have a difference of 5? You better believe it right there, the 2 and the 7. And so I'll have an x with a 2, x with a 7 equals 0. They multiply to be negative, so their signs are different. They add to be negative, so the bigger of them had to have that sign. So x plus 2, x minus 7. Both of those are set equal to 0, so using zero product property. And I get x equals -2 and x equals 7. So 2 answers came out of this, but beware. And yeah, this problem's starting to get long. I was going to say long in the tooth, but I'm not sure if I fully understand the meaning of that cliche. So anyways, it's starting to get long, but don't presume that those answers are true. We've got to do a check, and we've got to do a check on both of those in the original problem. So x plus 1 equals the square root of 7 times parentheses, which is the x, plus 15. And let's see, I'm going to cheat, and I'm going to screenshot this. Probably doesn't save me that much time, but I've got to check both of those things. So I'm going to plug in -2 first. So -2, -2 plus 1 is -1. Is that equal to the square root of -14 plus 15? -1 equals the square root of 1. -1 equals 1. Not true. Not true. And so this is extraneous. Extraneous. Extra, right? So that's not actually a solution. We did it right. It behaved the way we thought it should, but it did not work out. Also, I want to point out, notice this is a pure square root. It wasn't a plus or minus square root that could show up when solving quadratics. So yeah, so this square root of 1 is only 1, not plus or minus. Let's plug in 7 and see if we have better luck. 7 and 7. 7 plus 1 is 8. Is that equal to the square root of 49 plus 15? Is 8 equal to... I know what I want that to be. I'm tempted to be lazy and just assume. It is 64, though, yeah. Okay, and so 8 equals 8. That's true. Where's my green at? So, actual answer is only 1. There's only one answer in this case. Now, be careful. Sometimes both of the solutions that come out could be extraneous. And if they're both extraneous, then that would mean that there was no solution to the problem. So this problem takes up a bit of work. It requires patterns. It required factoring. It requires checks. You saw I even had that transcription error there, which would have bled through the whole problem, and I would have been wrong. But remember, I'm going to be trying to give you partial credit as best as I can. And even on the test, if you are socially distant and doing remote learning, I'm going to find a way to let you type multiple lines of code, and algebra rather, where I'll be able to give you partial credit. But it takes a little bit more effort. That's gonna be okay. It's gonna be okay. All right. For this one, tell you what, I'll just get it to the this part. So you would have squared both sides. You would have had 10x plus 9 equals. You would not distribute the exponent over plus, but you would have had a squared plus 2ab plus b squared. And so we would have had, what, 10x plus 9 equals x squared plus 6x plus 9. I would have subtracted 10x from both sides, and I would have gotten negative 4x. I would have subtracted 9 from both sides, and I would have gotten plus 0, which is just plain old that. Nothing. Don't have to write it. And this side would have had nothing. I have a quadratic set equal to 0, which means I can use the zero product property. In this case, there was no C term. But I could factor using our good old friend, greatest common factor. Oh, man, factoring coming back. It was gone for like a minute, but it's back. And then I would set each of these factors equal to 0. So either the x is equal to 0 or the x minus 4 is equal to 0. So this is one of my quote-unquote possible solutions. And then I get x equals 4 as the other. If I did a check, all right, guys, I was gonna not do this whole problem, but I'm doing so good. I'll do it. You can always skip forward if you want. So I would have had, what, the square root of 10 times x plus 9. Is that equal to x plus 3? Everywhere you see an x, you gotta plug in your possible solution. Let's see. So I would have plugged in zeros here. Right, I'm checking 0 first. So square root of is the square root of, I'm simplifying here, is the square root of 9 equals 3? Yeah, that's true. So that means this is a legit solution. Nice. How about for 4? Guys, you're gonna be annoyed. It's not exactly the same color blue. Oh, this one might be better though. So plug in 4. That's 40 plus 9 is 49. Is the square root of 49 equal to 7? Oh, that's also true. So this one had 2 solutions. So x equals 0 or x equals 4. Nice. Whew. All right. Oh, just when you thought it couldn't get any worse. Now, you might recall, step 1 was like, isolate the square root, right? Get the square root by itself on one side, square both sides. Actually, I even have that step up here, right? Isolate the radical. Now, the problem is that this has 2 radicals. And so I could get this one by itself, but then this one wouldn't be. This one's already by itself, and so I guess I'll work with that. And so I'm going to square both sides here. Oh, guys, hang on to your algebra hats. This is going to get crazy. And I want to point out, we're still going to have to use, can I get a clean screen shot of this pattern? Yeah, I can. Look at that. I'm still going to have to use this pattern. Okay, so this has multiple radicals. Now, tell you what, it does match this pattern over here. A is the square root of x plus 2. Horrible. And b equals 1. Now, I did say, and I honestly, for some reason, I so enjoy doing these problems. Like, the challenge of this boss fight, it's a worthy opponent. It's so good. And so I'm actually going to be plugging in the square root of x plus 2 everywhere I see an a. And so here we go. So a, oh dear, let me make sure that's a clean draw. A squared, this was a plus sign, so I'm using the plus version of the equation. A squared plus 2 times a times b, at least b is simple, plus b squared equals, and in this case, this side was easy. The square and the square root canceled out because this whole thing was underneath the square root. And so I've got 3 minus x. All right, so this whole piece, this cancels, shwip, shwip. So I've got x plus 2 plus 2 rad x plus 2 plus 1 equals 3 minus x. Notice, this is still crazy, but we're better off. We used to have 2 radicals, and now there's only 1. And I want to point out, you already know how to solve the kinds when there's only 1. What do? Let's isolate that radical and square both sides. Okay? All right. So I'm getting warmer. Okay? So even though this is still crazy, I am getting better. I can combine some like terms. So I'll have, let's see, 2 rad x plus 2 plus x, and the 2 and the 1 became 3 equals 3 minus x. All right, this is at least fortunate. Subtract 3 from both sides, guys. We're doing combo moves. I'm subtracting x from both sides as well. I'll have 2 rad x plus 2 equals, the 3's cancel out. I get negative 2x. Radical's not yet by itself. I'll divide both sides by 2. Rad x plus 2 equals the opposite of x. Now, I've isolated the radical. We've already squared both sides once. Guess what? We're doing it again. Oh man, we are chipping away at this boss fight. This is so great. Okay, I'm running out of space though. X plus 2 equals negative x all squared is going to become positive x squared. And I'm going to have to continue my work up here, I think. So I'm going to subtract x and subtract 2 from both sides. I'll get x squared minus x minus 2 equals 0. Okay, and so I set it equal to 0. It was a quadratic. It had a second degree. The only way you know how to solve at this moment in time is to set it equal to 0 and factor and solve. So let's see, is this factorable? Factors of 2 are 1 and 2. Do those subtract to be 1? You better believe they do. So I'll have an x with a 1, an x with a 2 equals 0. And let's see, they have different signs, and the bigger had to be negative. Because 1, 1, take away 2 would give me the negative 1 there. Split them up. Set each one equal to 0. Whoa. And subtract 1 from both sides. Add 2 to both sides. Notice we're skipping some algebra steps there. It's good, though. It's good. Okay. So, x equals negative 1, x equals 2. Even though I've done all of this work, I don't know if those are the answers. And so I'm going to have to do a check. Let's do a check. Check it, check it. So I'm going to have x plus 2 plus 1. Is that equal to the square root of 3 minus x? And I'm going to have to do this twice. Guys, I might run out of space. It's okay. So I'm going to plug in negative 1 everywhere there was an x. So negative 1 plus 2 is the square root of 1 plus 1. Is that equal to the square root of 4, right? Because 3 minus the negative 1 became plus. 1 plus 1 is 2. 2 equals 2. Ah, that's true. So this is a legitimate solution. Over here, I'm going to plug in the 2 everywhere there was an x. All right, I'm feeling good about this one. So this is square root of 4 plus 1. Is that equal to the square root of 1? I'm not feeling as good about it anymore. 2 plus 1. Is that equal to 1? That is not true. That was extraneous. Extraneous. Boom. And so this problem only had one solution. Takes a while to solve. Now, guys, notice I knew what I was doing, and it took me this long to solve it. These problems are serious, all right? They're going to require some attention. You got to do them. You got this, though. You got this. Okay? I've got like a reduced problem set for homework as well, so you'll be able to be okay. Now, here we are. Notice this doesn't have any radicals, but it does have a rational exponent, which can be written as a radical, right? Because you guys all remember that. So I could actually rewrite this as the fourth root, because the denominator of an exponent becomes the index of the radical of 2x. Tell you what, I'll put the all cubed on the inside there. Let's simplify that. So that's the fourth root of 8x cubed plus 2 equals 10. All right, so what do? I get the radical by itself. So I can move this 2. And so I'll have the fourth root of 8x cubed. Let me make a prettier 8 there. And we got to remember our properties of exponents and all that. Okay, radicals by itself on this side. So how do I get rid of a fourth root? Well, use the fourth root. Raise it to the fourth. Raise it to the fourth. And so 8 to the fourth power. I'm reaching for my Stormtrooper colored calculator. Come on, drawing tablet. 8x cubed equals 4096. Any 2048 fans out there? Let's see. Let's divide both sides by 8 now. I got x cubed equals div 8, 512. Ooh, I feel good about this one. I cube root both sides. Now, do I need a plus or minus? No, I don't, because it's an odd. I didn't even write the cube part. Because it's an odd index, you don't plus or minus. Boom. And I get x equals only one answer. Let's see. 3 second nth root 512 8. All right, so x equals 8. We technically got to do a check. Hey, you guys, you can fast forward the check parts if you need to at this point. So 2 ladle times 8 to the 3/4 power plus 2, is that equal to 10? 2 times 8 is 16 to the 3/4, or tell you what, let's write this as the fourth root of 16. I have a good feeling about that. Notice I'm putting the cube outside rather than inside this time because I knew that 16 was a perfect fourth. So that's 2 cubed plus 2 equals 10. 2 cubed is 8. 8 plus 2 equals 10. True! That's true. So, one answer only. All right, one last question. And here we go. All right, this is easy. Let's rewrite this as a square root. Notice the 1/2 was applied to the whole thing, so the whole thing is inside the square root. Nicely, this doesn't have two parts over here, right? If it had something else, then I'd have to use the whole pattern thing all over again. Okay, square x plus 30 equals x squared. All right, subtract x and subtract 30 from both sides. I'll get x squared minus x minus 30. I gotta set it equal to 0. And yeah, I mean, this part we're already at the, yeah, you know what's up by now. We've done the whole new thing here. Now this is all old stuff. But you can keep watching me. I'm doing it. Which of these subtract to be 1? Oh, that's the 5 and the 6. So I'll have an x with a 5 and x with a 6. Two separate factors equals to 0 plus 5 minus 6. So 0 product property, x plus 5 equals 0, or x minus 6 equals 0. Solve, subtract 5 both sides. Solve, add 6 both sides. And then I would do a check. Guys, I'm here I'll do the check. Here we go. Here we go. Make sure you watch my homework video as well. I'm going to do it, guys. I'm here with you the whole time. It's going to be okay. All right. So I've got to check it in the original equation, by the way. You can't just pick like an easier version of your equation like from later on in the quest. You know, you gotta do it all the way back at the beginning. Everywhere there's an x, I'm plugging in -5. I'm checking this answer. Is the square root of 25 equal to -5? Oh, no, it isn't. And let's see, let's try 6. I wonder, do we get a double extraneous finally? I wonder if we get a double extraneous. No, this one's gonna work. The square root of 36 equals 6 is true, and so 6 is the answer. If you had a problem where neither of them worked, both are extraneous, you would have just said no solution is the answer. All right, well, thank you. You're all troopers sticking in there. 30-minute video. Y'all have a good day, friends. Adios.